Tonight, we uncover the chilling possibility that the universe's origin story is a carefully constructed lie hidden behind the very light that was meant to explain us. Imagine for a moment that you are holding your family's most precious photo album. You begin to flip back through the pages past your graduation, your first steps, and your first birthday, searching for the very beginning, the moment you were born. But as you turn to the final page, the one reserved for your first baby photo in the maternity ward, you don't see a helpless, formless infant. You see a fully grown adult staring back at you with a lifetime of experience, scars, and stories etched into their face. This is the existential nightmare currently unfolding within the halls of NASA and the world's most elite astrophysical institutes. We spent $10 billion to build the James Webb Space Telescope, a time machine designed to witness the cosmic dawn. We expected to see the universe rubbing the sleep out of its eyes, a dark, chaotic nursery of cold, formless gas. Instead, we found ancient, mature, cosmic cities glowing in the absolute dark where nothing, not even a single star, should have had time to exist. The math of our reality is no longer just bending, it is snapping. And as the data continues to pour in from the edge of the observable universe, we are forced to confront a disturbing truth. The universe did not grow up the way we were told. It arrived already old, already structured, and already rebelling against the laws of physics. To understand why the scientific community is currently teetering on the edge of a total paradigm shift, you have to understand the sheer elegance of the lie we believed for 30 years. Before the first photon from the James Webb Space Telescope ever touched its golden mirrors, astronomers were certain they knew what the first galaxies looked like. They had spent decades building a masterpiece of a prediction, a model called lambda cold dark matter. It was a story of patience. In this version of history, the early universe was an agonizingly slow construction site. We expected to find huts, dim, messy, shapeless clumps of gas and newborn stars struggling to hold themselves together. No one expected cathedrals. We believed that building something as magnificent as our Milky Way, with its hundreds of billions of stars and elegant spiral arms, was a process that required eons. It was supposed to be a hierarchical crawl where small things gradually merged into larger things over billions of years, but this consensus was built on a foundation of total darkness. Before Webb, we were effectively blind to the first 500 million years of time. We were guessing, tracing shadows, and assuming that the rules we saw in the nearby universe applied to the very beginning. We had convinced ourselves that the universe began in a state of almost incomprehensible simplicity. We believed that after the initial fireworks of the Big Bang, the cosmos entered a period known as the Dark Ages. This wasn't just a lack of light, it was a total, uniform ocean of neutral hydrogen and helium gas. No stars, no galaxies, just an expanding, cooling fog that filled every cubic meter of space for 100 million years. In this dark ocean, gravity was supposed to be the slowest architect imaginable. It had to work against the internal pressure of the gas, waiting for it to cool down enough to finally collapse. And because the early universe was made of pure hydrogen and helium, elements that are notoriously terrible at shedding heat, the cooling process should have been a bottleneck that lasted for an eternity. This was the cosmic dawn we were prepared for. A long, quiet pause followed by the birth of the first lonely stars. These hypothetical population 3 stars were predicted to be giants, hundreds of times the mass of our Sun, living fast and dying young in the dark. But they were meant to be isolated pioneers. It was supposed to take hundreds of millions of additional years for these stars to seed enough heavy elements to allow the first real galaxies to assemble. This was the schedule of existence we had written for ourselves. It was a timeline that placed us, and everything we know, at the end of a very long and very logical road. Then, on a Tuesday, in July 2022, the James Webb Space Telescope opened its eyes and looked through a tiny sliver of sky no larger than a grain of sand held at arm's length. What it saw didn't just challenge our models, it felt like a personal insult to the physics we had spent a century perfecting. Within that microscopic patch of the void, there weren't just the faint smudges of baby galaxies we had been promised. There were thousands of them, and among them were objects that looked far too bright, far too structured, and far too massive for their age. The photo album paradox had officially begun. One of the first objects to break the world's heart was a galaxy that would eventually be named JWST-GS-Z14-0. When the team of researchers first saw the data, they didn't believe it. They assumed it was a glitch, or perhaps a closer galaxy whose light had been warped by a cosmic illusion. But the spectra didn't lie. This galaxy was sitting at a distance that placed it just 290 million years after the Big Bang. In cosmic terms, that is the blink of an eye. If the universe were a 100-year-old human, this galaxy appeared when the universe was barely a 2-year-old toddler. According to our huts versus cathedrals model, a galaxy at this age should be a chaotic, metal-poor wisp of gas. But JWST-GS-Z14-0 is a monster. It is over 1,600 light-years across and contains hundreds of millions of stars. It is glowing with a ferocious ultraviolet luminosity that suggests it is not just forming stars, it is speed-running the entire process of cosmic evolution. It is as if we planted an acorn, walked away for 10 minutes, and returned to find a mature, deep-rooted oak tree towering over the garden. But the size isn't even the most disturbing part. The truly terrifying discovery was the chemical signature hidden within its light: oxygen. To a chemist, oxygen is common. To an astronomer looking at the birth of the universe, oxygen is an impossibility. You cannot have oxygen without multiple generations of stars living, dying, and exploding. Oxygen is forged in the nuclear furnaces of stars. It is not a starter element provided by the Big Bang. Finding significant amounts of oxygen in a galaxy that is only 290 million years old means that a whole cycle of stellar life and death had already occurred before the galaxy even reached the point where we see it. It suggests that the pre-dawn era, the time we thought was empty and dark, was actually a period of violent, hyper-efficient star formation that our models completely missed. It implies a chemical pre-dawn that shouldn't exist, as if the universe was already cooking its heavy elements in a hidden era of history. This discovery sent a shockwave through the community that is still vibrating today. If JWST-GS-Z14-0 is real, and we now know it is, then our map of how the universe builds itself is fundamentally broken. We are seeing a level of maturity that suggests structure emerged from chaos far faster than gravity should allow. It's as if the early universe was running on a turbo mode we don't understand. Some scientists have tried to stay calm, suggesting that perhaps we just need to tweak the math of star formation. They argue that maybe the early universe was just better at making stars than we are today. But a growing number of cosmologists are starting to suspect that the problem is much deeper. They are looking at the isotropic imbalance, a strange, overlooked detail in the latest surveys, suggesting that these early galaxies aren't just growing too fast, but they are rotating with a preferred orientation. Our standard model assumes the universe is isotropic, meaning it should look the same in every direction. But the JWST data shows a bias in the spin of these early structures, a primordial spin that hints at a hidden architecture. It suggests the universe wasn't born as a blank canvas, but rather as a structure with an inherent twist or memory, perhaps inherited from a parent universe or rotating black hole that birthed our own. This is the architecture of cosmic rebellion. We find ourselves staring at a sky that refuses to behave. We are seeing red monsters, galaxies so massive and so chemically enriched that they appear to have converted nearly 100% of their available gas into stars, while the modern universe is a leaky faucet that wastes 90% of its raw material. We are seeing a universe that was more active, more aggressive, and more alive in its infancy than we ever dared to imagine. As we close this first chapter of our investigation, the question is no longer whether we were wrong about the first galaxies. The question is, if we were wrong about the beginning, how much of the rest of the story is a fiction? We set out to find our origins, but we may have stumbled upon a cosmic imposter, a universe that is much older, much stranger, and far more dangerous to our understanding of reality than we ever thought possible. And the deeper we look, the more it feels like the universe isn't just expanding, it's trying to tell us that we've missed the most important part of the story. To understand the full magnitude of the rebellion we are witnessing, we have to look at a single point of light that nearly broke the instruments designed to find it. This is the story of JWST-GS-Z14-0, a name that sounds like a clinical serial number, but represents the single greatest disruption in the history of modern cosmology. In the halls of NASA's Goddard Space Flight Center, it wasn't a sudden explosion that signaled the crisis. It was a smudge of red light that was too bright, too big, and far too early. To appreciate the impossible nature of this galaxy, imagine a gardener planting a single acorn in a flower pot. He presses the seed into the soil, turns his back to grab a watering can, and when he turns back around, less than 10 minutes later, a mature 100-foot-tall oak tree is towering over him, its roots already cracking the ceramic pot, and its branches heavy with a lifetime of growth. This isn't just a metaphor for JADS-GS-Z14-0, it is a literal description of the temporal impossibility this galaxy presents to our current understanding of time. Our best models of the universe, the ones we have spent decades refining with supercomputers and Nobel Prize-winning math, told us that 290 million years after the Big Bang, the universe should have been a primitive nursery. At this age, less than 2% of its current life, gravity was supposed to be a slow, clumsy architect. We expected to see huts, small, chaotic clumps of hydrogen gas where a few thousand stars were just beginning to flicker into existence. Instead, the golden mirror of the James Webb Space Telescope looked into the void and saw a cathedral. JADS-GS-Z14-0 is a functioning stellar city spanning over 1,600 light-years across. It isn't a collection of a few lonely stars, it contains hundreds of millions of suns, all burning with a ferocious ultraviolet intensity that shouldn't be physically possible so soon after the birth of space and time. The discovery of this oak tree in the flower pot was not an easy pill for the scientific community to swallow. When the JADS team, short for the JWST Advanced Deep Extragalactic Survey, first pulled the data from the Deep Space Network, there was an immediate, instinctive search for an error. In science, when you find a result this extreme, your first thought isn't eureka, it's what did we break? There was a desperate hope that this was a cosmic imposter, perhaps a closer, ordinary galaxy whose light had simply been warped or misidentified by the telescope's software. On the sky, the red smudge sat perilously close to a foreground galaxy, leading some researchers to believe the two were neighbors, or that the closer object was somehow polluting the data. To resolve the ambiguity, the team had to commit to one of the most ambitious and high-stakes observations in the history of the mission. They dedicated 75 hours of Webb's precious time to a single spectroscopic campaign, staring at that one tiny patch of blackness for over 3 days. The resulting data was a death knell for the old consensus. The spectrum showed a Lyman break, a clean, sharp cutoff in the light that occurs when neutral hydrogen gas in the early universe absorbs ultraviolet radiation. The position of that break confirmed, beyond any statistical doubt, that the galaxy sat at a redshift of 14.32. This isn't just a distance, it is a timestamp. It places JADS-GS-Z14-0 firmly in an era where the universe was still supposedly rubbing the sleep out of its eyes. But the size and the age are only the beginning of the nightmare for theorists. When the team analyzed the light from JADS-GS-Z14-0 more deeply, they discovered something that the original ground-based surveys had completely missed. The stars within this galaxy were already 90 million years old. Think about what that implies. If the galaxy is being observed at 290 million years and the stars are already 90 million years old, it means the seed for this massive structure had to have been planted and ignited just 200 million years after the Big Bang 10. This pushes the cosmic dawn, the moment the very first stars turned on, back into a region of history that was supposed to be a dark, featureless ocean of gas. The sheer overachievement of this galaxy is what makes it a rebel. In the modern universe, star formation is a notoriously inefficient process. We see giant clouds of gas and dust that take millions of years to collapse, often wasting 90% of their material as it gets blown away by radiation pressure or internal heat. But JWST-GS-Z14-0 appears to have been operating in a turbo mode. It converted gas into stars with nearly double the efficiency we see today, behaving less like a gradual cosmic evolution and more like a startup that somehow became a trillion-dollar company in a week. What's even more disturbing is that we cannot blame this brightness on a hungry black hole. In many of the other impossible galaxies found by Webb, scientists have found relief in the little red dot theory, the idea that a supermassive black hole at the center is doing all the work, outshining its host galaxy and tricking us into thinking there are more stars than there actually are. They call it the flashlight tape to a candle effect. But JWST-GS-Z14-0 refused to give them that exit ramp. The light from this galaxy isn't coming from a central, concentrated point of accretion. It is coming from a vast, extended halo of young, hot stars spread across the entire 1,600 light-year span. It is a galaxy that decided it didn't need a central engine to glow. It was going to set the entire sky on fire with its own sheer mass. As the researchers stared at the final confirmation of JWST-GS-Z14-0, the mood shifted from academic curiosity to a creeping sense of existential dread for the standard model. If you have one outlier, you can call it a freak of nature. But JWST-GS-Z14-0 was just the first to be confirmed. Soon, another record fell to a galaxy named MOM-Z14, existing just 280 million years after the beginning, showing even more advanced chemical signatures. The lake of evidence was growing, and the puddles of our old theories were being swallowed up. We are looking at a universe that was speed-running its own development. It was building structures that were too big, too structured, and too mature for a timeline that was supposed to be dictated by the slow, gravitational pull of dark matter. It suggests that our photo album of the universe's birth is missing a massive, violent, and highly efficient chapter, an era where the rules of physics might have allowed for a kind of stellar wildfire we have no modern analog for. But there is a final detail in JWST-GS-Z14-0 that is perhaps the most disturbing of all, a detail that hints at a chemical complexity that should be impossible in a first-generation structure. Hidden within the ultraviolet glow of those hundreds of millions of stars, the spectrometers picked up the unmistakable signature of heavy elements, specifically oxygen. In a universe that was supposed to be made of pure, pristine hydrogen and helium, finding oxygen is like finding a piece of modern plastic buried in a prehistoric dinosaur fossil. It is a signal that the oak tree hadn't just grown too fast. It had already lived, died, and scattered its ashes before we even saw it bloom. This chemical paradox is the next loop in the mystery, one that suggests the early universe wasn't just building fast. It was building with ingredients rebellion of JWST-GS-Z14-0. We must first look at our own hands, the air filling our lungs and the iron coursing through our veins. There is a poetic comfort in the old saying that we are made of star stuff, but for decades that was more than just a sentiment. It was a rigid, mathematical timeline. We believed we knew exactly how long the universe had to labor in the dark before it could produce the complex ingredients of life. We thought the first chapter of the cosmos was written in a simple, lonely alphabet of just 3 letters: hydrogen, helium, and a vanishingly small trace of lithium. This was the starter kit of the Big Bang, the raw, primitive material provided by the initial explosion. You can build a star out of hydrogen, but you cannot build a planet. You certainly cannot build a person. To get from a featureless fog of gas to a functioning biological entity, the universe had to become a chemist. It had to forge heavier elements, what astronomers call metals, in the only furnaces capable of such alchemy, the hearts of stars. This process, known as nucleosynthesis, was always understood as a slow, generational marathon. A star must form, it must live for millions or billions of years, and then it must die a violent death to scatter its forged elements into the void. Only then can a second generation of stars form from that enriched dust, and perhaps a third, until finally the universe has enough grit to build things of substance. This was the cosmic schedule we lived by, but JWST-GS-Z14-0 has just torn that schedule to pieces. When the James Webb Space Telescope analyzed the light from this galaxy, it didn't just see the glow of primeval stars. It detected the unmistakable chemical signature of doubly ionized oxygen. To a chemist, oxygen is common. To a cosmologist looking at the dawn of time, finding oxygen in JADES-GS-Z14-0 is like digging into a pristine, undisturbed layer of Jurassic Earth and finding a smartphone. It is a chemical anachronism, a piece of the future sitting in the deep past. Because oxygen is not a starter element. It was not provided by the Big Bang. Every single oxygen atom in existence was manufactured deep inside the nuclear core of a massive star that eventually exploded as a supernova. This means that for Webb to see oxygen in a galaxy that existed just 290 million years after the Big Bang, a whole cycle of stellar life and death had to have already occurred before we even saw the galaxy. The oak tree we found in the maternity ward wasn't just fully grown, it had already dropped its seeds and seen a second generation rise in its shadow. The math of this discovery is where the oxygen impossible truly begins to hurt. According to our most robust models, the first stars, the hypothetical population 3 giants, didn't even flicker into existence until about 100 to 200 million years after the Big Bang. These stars were supposed to be the pioneers, massive blue monsters hundreds of times the mass of our Sun, burning hot and dying young. They were the ones tasked with the initial heavy lifting, the ones who would forge the first scraps of carbon and oxygen. But if JADES-GS-Z14-0 is already packed with oxygen at 290 million years, and its stars are already 90 million years old, that leaves a window of time so narrow it defies the known laws of gravitational collapse. In this version of history, the universe had less than 100 million years to ignite the first stars, watch them burn through their fuel, see them explode as supernovae, wait for that enriched gas to cool down, which is a notoriously slow process, and then collapse that gas again into the massive, mature galaxy we are now observing. It is a speed run of cosmic evolution that should be physically impossible. It suggests that the dark ages, that long, quiet pause we thought lasted for an eternity, was actually a period of frantic, violent star formation that we completely missed. We expected a cosmic dawn that looked like a slow, gentle sunrise. Instead, JADES-GS-Z14-0 tells us it was more like a 5-alarm blaze that erupted in the dark before the wood had even dried. But the mystery goes deeper than just the speed of construction. It touches on the efficiency of the early universe. In the modern cosmos, star formation is a messy, wasteful business. Only a tiny fraction of gas in a cloud actually becomes a star. The rest is blown away by radiation or remains trapped in a lukewarm state. We call the modern universe a leaky faucet, but JADES-GS-Z14-0 and the other red monsters being found in its wake appear to have operated at nearly 100% efficiency. Every atom of available gas was converted into a star with a speed that suggests a turbo mode in the early universe that we don't understand. Why was the early universe so much better at building than the universe is today? One theory being whispered in the halls of research institutes is the lithium problem. For years, we've known our Big Bang models are slightly off. They predict 3 times more lithium than we actually find in ancient stars. This lithium problem was a quiet crack in the foundation that we tried to ignore. But now, with the discovery of impossible oxygen, that crack is becoming a canyon. If the Big Bang's chemical inventory was different than we assumed, or if the physics of nuclear fusion worked differently in the high-density environment of the infant universe, then the entire story of how we were made is a fiction. Finding oxygen at the edge of time implies a chemical pre-dawn that wasn't supposed to exist. It suggests that the universe was already cooking its heavy elements in a hidden era of history that we are only now beginning to see. And oxygen isn't the only culprit. Other record breakers, like the Galaxy MOM-Z14, have shown elevated levels of nitrogen as early as 280 million years. Nitrogen is even harder to produce than oxygen. It requires a specific cycle of fusion that typically takes even more time and more stellar generations to accumulate. Finding these elements in the toddler phase of the universe is like seeing a 2-year-old child who isn't just speaking, but is writing a thesis on organic chemistry. The psychological impact of this cannot be overstated. For decades, we felt secure in our timeline. We believed that the complexity of the world, the rocks, the water, the oxygen in our blood, was a hard-won prize achieved over billions of years of patient stellar labor. But JWST-GS-Z14-0 suggests that the complexity was there almost from the beginning. It implies that the universe didn't learn how to make us over eons. It arrived already knowing the recipe. As we stare into the infrared data from Webb's NIR spec instrument, we aren't just looking at light. We are looking at the DNA of the first structures. And that DNA is too advanced. It is too mature. It is a signal from a universe that is rebelling against our attempts to simplify it. If multiple generations of stars lived and died in the absolute dark before the first 300 million years had passed, then the dark ages were never dark. They were a period of intense, hyper-efficient activity that our models simply weren't designed to capture. This leads us to a disturbing crossroads. Either our models of how long it takes to build a star are catastrophically wrong, or the universe is much older than 13.8 billion years, or, perhaps most unsettling, there is an invisible hand at work in the physics of the early universe. We are finding that the cosmic dawn was less of a beginning and more of a second act. We have spent billions of dollars to build a time machine to see the start of the story, only to realize we've walked into the theater halfway through the movie and the plot is already moving at terminal velocity. If JADES-GS-Z14-0 is an oak tree in a flower pot, then the oxygen inside it is the proof that the soil was already rich with the ashes of an even earlier forest. We are forced to ask, where did that forest come from? How did it grow in the dark? And if the universe was already this alive and chemically rich while it was still a toddler, what other secrets has it been hiding in the era we used to call the void? The more we look, the more it feels like we aren't just missing a detail. We are missing a fundamental chapter of reality. And as we will soon see, the impossible brightness of these galaxies might be hiding an even darker secret, monsters lurking in the red light that were never meant to be found. For while the oxygen tells us how fast the stars were living, a different population of objects is about to tell us how fast the darkness itself was growing. We call them the little red dots, and they are about to prove that the universe's early maturity wasn't just a miracle of starbirth, but a terrifying efficiency. The crimson veil of the early universe to reveal the terrifying truth about the monsters lurking in the shadows of the Big Bang. As the James Webb Space Telescope stared into the deepest, most silent corners of the cosmos, it began to pick up a signal that wasn't just a mystery. It was a warning. Scattered across the first billion years of time, astronomers discovered hundreds of tiny, intensely red pinpricks of light that appeared to be the most efficient factories of matter ever conceived. At first glance, these objects looked like massive galaxies packing the entire weight of the Milky Way into a space smaller than a single star cluster, a density of stars so extreme it challenged the very geometry of space-time. But as the data deepened, the crisis took an even darker turn, suggesting that what we were seeing weren't galaxies at all, but something far more predatory. We are now forced to confront the flashlight taped to a candle paradox, where the light we once thought came from a billion stars is actually the death howl of gas being devoured by black holes that, by all the laws of physics, simply should not be there. While we were still grappling with the chemical impossibility of the first galaxies, a new population of anomalies began to emerge from the darkness, a population that the scientific community quickly nicknamed the Little Red Dots. By 2025, over 340 of these enigmatic objects had been catalogued, appearing primarily between 600 million and 1.6 billion years after the Big Bang. On the surface, they looked like red monsters, ultramassive galaxies that had somehow achieved total maturity in a fraction of the time allowed by our models. When astronomers first estimated their properties, the numbers that came back were borderline absurd. These objects appeared to contain as many stars as our own Milky Way, but they were compressed into a volume 1,000 times smaller. To put that into a perspective that is truly disturbing, if you were to shrink the Milky Way down to the size of one of these little red dots, the nearest star to our Sun, Proxima Centauri, would no longer be light years away. It would be sitting comfortably inside our own solar system. The massive black hole at the center of our galaxy, which currently sits 26,000 light-years away, would be only 26 light-years from Earth, close enough to shine in our night sky with terrifying intensity. The sheer density of such a system would be a gravitational pressure cooker, a place where stars would be colliding and merging at a rate that would make life, or even stable planetary orbits, a physical impossibility. Headlines immediately erupted, claiming that these universe-breaking galaxies had effectively destroyed the standard model of cosmology. If the universe could build something that massive, that quickly, then our entire timeline was a lie. But as elite research teams at the University of Texas and beyond began to dissect the light from these red pinpricks, they realized they were being fooled by a cosmic illusion. The spectra of these objects didn't show the smooth, gentle glow of billions of stars. Instead, they showed broad emission lines, the telltale signature of gas screaming at extreme velocities. These weren't galaxies packed with stars, they were monsters in disguise, supermassive black holes outshining their entire host galaxies. This is where we encounter the flashlight taped to a candle analogy. Imagine standing on a dark, desolate plain at night. In the distance, you see a brilliant, concentrated point of light. Based on your understanding of candles, you calculate that for a light to be that bright, at that distance, there must be 1 billion candles all burning in a tight cluster. You do the math, you estimate the mass of the wax, and you conclude that you are looking at a massive, impossible structure. But when you walk closer, you realize there aren't 1 billion candles. There is only one candle, and someone has taped a high-powered military flashlight to it. The flashlight, the black hole's accretion disk, is doing all the work, producing a blaze of light and heat so intense that it tricks your senses into seeing mass that isn't there. An active galactic nucleus, AGN, is powered by gas, spiraling into a central black hole heated by friction to millions of degrees. This process is so efficient that a single black hole can produce more light than the hundreds of billions of stars in its host galaxy combined. By identifying the little red dots as these hungry black holes, the mass crisis for galaxies seemingly evaporated. The galaxies were much smaller and lighter than we thought. They just looked massive because their central engines were turned up to full blast. However, solving the galaxy problem only traded it for an even more disturbing black hole problem. If these little red dots are indeed supermassive black holes, then we have a major collision with the Eddington limit, the fundamental speed limit of cosmic growth. Arthur Eddington proved that there is a maximum rate at which a black hole can feed. As gas falls in, it radiates energy. That radiation exerts an outward pressure that pushes the remaining food away. If you try to feed a black hole too fast, it chokes on its own energy and the growth stops. To reach 1 million solar masses, the size of the monsters we are seeing just 400 million years after the Big Bang, a black hole starting from a seed left behind by a dead star would need to double its mass every 50 million years. This would require nearly 800 million years of continuous maximal feeding without a single interruption. But the universe is finding these monsters when it is only 300 or 400 million years old. The math doesn't work. We are seeing monsters without mothers, giants that arrived in the universe already fully grown. This leaves us with two unsettling possibilities. The first is that these black holes were born big through direct collapse. In the high-density chaos of the early universe, massive clouds of gas might have skipped the star-building phase entirely, collapsing monolithically into a black hole the size of 1,000 suns in a single violent event. This would give them a massive head start, allowing them to reach supermassive scales within the impossible timeline. The second possibility is even more radical, that the little red dots are not conventional black holes at all, but supermassive primordial stars. These population 3 behemoths, weighing 1 million times more than our Sun, would live for just a few thousand years before collapsing. If Webb is catching them in their final moments, we are seeing a class of object that hasn't existed in the universe for 13 billion years, a transitional ghost between the first light and the first darkness. There is also a fringe theory emerging from the latest data that suggests we might be seeing something else entirely. A study published in early 2026 proposed that the broad emission lines we use to identify these black holes might be an illusion caused by electron scattering in extremely dense cocoons of ionized gas. If this is true, the black holes might be 1,000 times smaller than we think, but they are accreting material at a rate that is super Eddington, meaning they are somehow breaking the laws of radiation pressure and eating their surroundings at a speed that shouldn't be physically possible. As we remove these little red dots from our surveys, the cosmological crisis begins to soften, but it refuses to disappear. Even without the black hole contaminants, there are still twice as many massive galaxies as our models predict. The red monsters were real, they were just partially obscured by the flashlights of the black holes. This suggests that the early universe was operating in a turbo mode we still don't understand, a period where both stars and black holes were competing to see who could conquer the darkness first. The existence of the little red dots tells us that the early universe was not a quiet nursery, but a howling void of rapid construction and efficient destruction. We went looking for the beginning of the story, but we found a universe that was already deep into its most violent chapter. The flashlight has illuminated a gap in our knowledge that no amount of tweaking the math can fix. We are looking at a universe that arrived already old, already structured, and already inhabited by monsters that seem to have skipped the process of being born. And as we will see in the next chapter, even the two big galaxies that remain after the black holes are gone carry a secret about how they were built. A secret that suggests the very vacuum of space was once a far more productive and dangerous place. The little red dots began to offer a temporary shelter for our broken models. The relief was short-lived. In the cold, analytical light of the morning after, the census of the early universe still refuses to balance its books. When we peel back the masks of the hungry black holes and discount the cosmic imposters, we are left with a ghost that refuses to be exorcised. Even without the monsters in disguise, the James Webb Space Telescope is staring at a population of galaxies that is still, stubbornly, twice as massive as our most sacred laws of physics say they are allowed to be. This is no longer a matter of mistaken identity, it is a fundamental crisis of production. We find ourselves staring at the too early, too big problem, a reality where the early universe didn't just build fast, it built with an efficiency that borders on the supernatural. To understand why this is a nightmare for cosmologists, you have to look at the universe as a manufacturing plant. In the modern cosmos, the factory of star formation is a catastrophic failure. If you were to walk into a modern galactic warehouse and hand over 100 tons of raw hydrogen gas, the management would take that material, process it for a few million years, and at the end of the line, they would hand you back just one single star. The other 99 tons of gas would be gone, blown out the vents, scattered by the heat of the machines, or simply left to drift uselessly on the floor. Astronomers call this the leaky faucet of the modern universe. For every atom that successfully collapses into a sun, dozens more are rejected by the very process of creation. But when Webb looks back to the first 500 million years, it finds a factory that is running in a terrifying efficiency mode. Those early galaxies, these red monsters, didn't waste anything. They appear to have operated at nearly 100% efficiency, converting every single scrap of available gas into a star as if they were in a desperate race against a deadline we can't see. It is as if the laws of management changed. Why did the early universe know how to use every grain of its raw material, while the universe we inhabit today has become a wasteful, bloated relic that squanders 90% of its inheritance? To understand the mechanics of this leaky faucet, you have to understand the violence of birth. When a star is born, it doesn't do so quietly. A massive newborn star is a furnace of radiation and stellar winds so powerful they act like a galactic leaf blower. As soon as the first stars in a cloud ignite, they begin pushing away the very gas that was trying to form their neighbors. Then comes the final insult, the supernova. When a massive star dies, it explodes with a force that can clear an entire neighborhood of star-forming material. This is stellar feedback. It is the universe's internal regulator, a system of checks and balances designed to prevent galaxies from growing too fast. It is the reason the Milky Way isn't 10 times larger than it is today. Feedback is the hand that turns the faucet to a trickle, but in the early universe, that hand appears to have been paralyzed. In the densest, most primitive corners of the infant cosmos, the gravity was so intense and the environment so packed that the leaf blowers of radiation and the dynamite of supernovae weren't enough to stop the collapse. The early universe was roughly 1,000 times denser on average than it is today. In that high-pressure environment, the gravitational wells were so deep that even when a star exploded, the gas couldn't escape. It was trapped, held in a vice grip by the dark matter and the sheer weight of the surrounding medium, forced to fall back and become a star again and again. This leads us to a disturbing realization. The photo album paradox might exist because the early universe was a place where the rules of engagement were fundamentally different. In our local neighborhood, we see a universe that is calm, sparse, and regulated. But the red monsters were born in a state of cosmic rebellion, a time when gravity had a total, uncontested victory over the forces of light and heat. If star formation efficiency in the early universe was truly 5 to 10 times higher than it is today, then we aren't just looking at early galaxies. We are looking at a different kind of physics, a turbo mode of existence, where structure was mandated by the sheer density of the Big Bang's leftovers. However, there is another, perhaps even more unsettling possibility being debated in the halls of the Flatiron Institute and Northwestern University. What if the galaxies aren't actually as massive as they look? What if we are being fooled by a trick of timing? This is the firefly effect. Imagine you are standing in a dark field at night and you see a sudden, brilliant flash of light. You take a photo, and when you look at the image, you see a glowing orb so bright you assume it must be a massive searchlight. But the truth is simpler. It was just a firefly that happened to blink at the exact millisecond your shutter was open. If you had waited 10 seconds, the field would have been pitch black again. New supercomputer simulations like those from the FIRE project, feedback in realistic environments, suggest that early galaxies were bursty. Because they were so small and their gravity was so shallow, their star formation didn't flow like a river, it flashed like a strobe light. In this model, a galaxy would experience a violent, hyper-efficient burst of star birth that would make it glow with the intensity of 1 billion suns for a few million years. Then the collective heat of those stars would finally win, blowing the gas out and turning the galaxy off into a period of total darkness. Then gravity would slowly pull the gas back in and the cycle would repeat. If this bursty mode is real, it means the James Webb Space Telescope is essentially a camera catching the universe in a series of flashes. We see so many bright, massive galaxies not because they are all that way all the time, but because we only see the ones that are currently blinking. The impossible galaxies might just be ordinary, small clumps of gas that we happen to catch during their most glorious fleeting moments. But even the firefly effect struggles to explain the sheer total mass some of these objects have accumulated. If you catch enough fireflies, eventually you have to admit there's a lot of insects in the field. And that brings us to the initial mass function wildcard, the possibility that the very DNA of stars was different. In the modern universe, for every one massive, bright blue star, the factory produces hundreds of tiny, dim red dwarfs. It's a bottom-heavy distribution. But in the early universe, where heavy elements like carbon and oxygen were missing, gas clouds couldn't fragment into small pieces. They stayed large, hot, and bloated. This would create a top-heavy universe, an era where the factory only made the big models. If the first galaxies were made primarily of these massive, short-lived giants, they would look 10 times brighter than a modern galaxy of the same mass. We would look at them and calculate a massive weight, when in reality, we are just seeing a few very bright lights. It's the ultimate cosmic illusion, a lightweight galaxy posing as a heavyweight because it's wearing a coat of brilliant blue stars. Yet, as soon as we think we've found the exit ramp, the data bites back. A 2025 study of the descendants of these early galaxies, older systems closer to us that should have been those red monsters billions of years ago, found exactly the opposite. Their stellar populations weren't top-heavy, they were bottom-heavy, packed with more tiny, low-mass stars than even the Milky Way. If these are the children of the red monsters, then the problem isn't that the galaxies look too bright, it's that they were actually even heavier than we thought. The leaky faucet wasn't just fixed, it was replaced with a high-pressure fire hose of star birth that produced more mass in less time than any simulation can replicate. We are left standing in the middle of a scientific reckoning. Whether it was the sheer crushing density of the infant universe, the strobe light flashes of bursty mode, or a fundamental shift in the DNA of how stars are born, the conclusion is the same. The early universe was not the slow, patient builder we imagined. It was an aggressive, hyperproductive, and violently efficient machine. We have spent decades building a story of a universe that took its time to grow up, a universe of patience and gradual mergers. But Webb has shown us a universe of speed running and efficiency mode, a universe that arrived at the finish line before we even thought the race had begun. And as we look closer at these too early, too big structures, we are beginning to see something even more disturbing than their mass. We are seeing order. We are seeing galaxies that aren't just big, but are organized into elegant rotating disks and spiral arms, structures that should have taken billions of years of calm to settle. We are finding adults in the maternity ward, and they aren't just sitting there, they are dancing. In the next chapter, we look at the most organized rebel of them all, a galaxy that shouldn't just be too big, but should be too chaotic to have a shape. And yet, it looks exactly dark like room where time itself feels like a physical weight, and on opposite walls, 2 clocks are ticking. Both clocks were built by the finest master craftsmen humanity has ever produced. Both have been tested, retested, and calibrated with a level of precision that borders on the obsessive. The first clock, reflecting the ancient light of the Big Bang, tells you it is 6:07, while the second clock, measuring the movement of the stars right outside your window, insists it is 6:13. These clocks do not just disagree, they represent 2 entirely different versions of history. This is not a thought experiment. It is the current state of modern cosmology, a phenomenon known as the Hubble tension. There is a single number that is currently breaking the laws of physics, not bending them, not stretching them, but shattering them. That number is the Hubble constant, the speed limit of reality, and it tells us how fast the very fabric of space is stretching right now as you sit here breathing. To understand why this disagreement has reached the level of a cosmic crisis, we have to look at the first clock, the one that peers back to the very beginning. This is the method used by the European Space Agency's Planck satellite, which mapped the oldest light in existence, the cosmic microwave background. This light is a whisper from a time when the universe was only 380,000 years old, a period so early that if the entire history of the cosmos were compressed into a single calendar year, this light was emitted in the first 15 minutes of January 1st. At that moment, the universe was a blinding hot fog where photons were trapped, unable to move until the cosmos cooled enough for the first atoms to form. When that fog finally lifted, light was released to travel freely for 13.8 billion years, carrying with it a baby picture of the infant universe. The Planck team didn't just look at this picture, they read it like a cross-section of an ancient tree, extracting information about the density of matter, the heat of the Big Bang, and the frozen echoes of sound waves that rippled through the primordial fire. They took these measurements and fed them into the standard model of cosmology, our best set of equations for how the universe evolves. The model ran the clock forward across billions of years of expansion and galaxy formation to predict what the expansion rate should be today. The answer was 67.4 kilometers per second per megaparsec. The uncertainty on this number is tiny, reflecting a measurement of almost frightening precision. The Planck team was not guessing. They had wrung every drop of information from the oldest light in existence to project a definitive must for our current reality. But on the other side of the room, the second clock was being built with a completely different set of tools. This clock doesn't project from the past, it measures the present. Led by Nobel laureate Adam Rees, the JWST team used the cosmic distance ladder to look at real stars and real galaxies moving away from us right now. They started with Cepheid variables, stars that pulse with a rhythm as steady as a heartbeat, where the speed of the pulse reveals their true brightness. By measuring these pulses, they can calculate exactly how far away a galaxy is, just as you can judge the distance of a candle by how dim its flame appears. At the top of this ladder are Type 1, a supernovae, exploding stars that briefly outshine entire galaxies and serve as standardizable candles for reaching even deeper into the void. By combining these rungs, the JWST team arrived at a number 73 kilometers per second per megaparsec. The gap between 67 and 73 is roughly 6%. In your daily life, a 6% difference in a grocery bill or a morning commute is background noise, but in the world of cosmology, where measurements are precise to within 1%, 6% is not a detail, it is an earthquake. It is the sound of a building starting to shift because the blueprint and the tape measure no longer agree. For years, the scientific community tried to stay calm, assuming that the local measurement of 73 must be an error. The primary suspect was a phenomenon called stellar crowding. Because Cepheid variables live in the dense, dusty hearts of spiral galaxies, it was thought that the older Hubble Space Telescope was simply not sharp enough to separate the light of the individual pulsating star from the glow of its neighbors. If the light was blended, the star would appear brighter than it actually was, making the galaxy seem closer and the expansion rate appear faster than it truly was. The hope was elegant: fix the blending, and the Hubble constant would slide back down to 67, the standard model would be saved, and the crisis would dissolve. The James Webb Space Telescope was sent to be the ultimate arbiter of this dispute. Floating 1,000,000 miles from Earth, equipped with a 6.5-meter golden mirror and infrared eyes that can pierce through cosmic dust, Webb was designed to resolve these crowded star fields once and for all. Scientists were so confident that Webb would find the error in Hubble's data that some had essentially written the conclusion before the data even arrived. They expected the Cepheids to look dimmer, the distances to stretch, and the expansion rate to drop. But when Webb's data finally trickled back to Earth in early 2024, the universe refused to be fixed. Webb did not bring the number down. Instead, it confirmed Hubble's measurements almost exactly, revealing that stellar crowding was never the problem. The telescope sent to end the crisis had, in fact, verified it. Adam Rees looked at the data and concluded that we may have fundamentally misunderstood the universe. David Gross, another Nobel laureate, was even more blunt, insisting that we stop calling it attention and start calling it what it is: a crisis. This crisis reaches into the very foundations of the timeline we have built for ourselves. The expansion rate is not just a speed, it is the master dial that controls the age and size of everything we know. If the universe is expanding at 67, it has been stretching for 13.8 billion years. But if the rate is 73, everything converges to a point much sooner. In this faster expanding universe, the Big Bang happened more recently, making the cosmos perhaps a billion years younger than we believed. To erase a billion years from history is to compress the entire schedule of existence. It means the photo album paradox we discussed in the first chapter is actually much worse than we thought. If the universe is a billion years younger, then those mature, metal-rich red monster galaxies didn't just appear too early. They appeared when the universe was essentially an infant that hadn't even learned to crawl. Every stage of cosmic evolution, from the first stars igniting to the formation of heavy elements like oxygen and nitrogen, would have had to happen in a window of time that is now even narrower, even more impossible. This conflict suggests that there is a missing chapter in the equations of reality, some hidden force or extra push that our models do not include. Some theorists propose early dark energy, a hypothetical burst of energy that kicked the expansion into high gear shortly after the Big Bang, while others wonder if dark matter itself behaves in ways we have yet to imagine. But the truth is that right now we are standing at the edge of what we know. We have two master-crafted clocks telling us two different stories about the same universe. As we stare at the impossible galaxies of JD's GS Z14-0 and the red monsters that shouldn't exist, we must face the reality that the problem might not be with the galaxies themselves. The problem might be the very ground we are standing on, the 13.8 billion-year timeline we treated as an absolute truth. If the expansion rate is truly 73, then the universe didn't just grow up fast, it arrived in a state of rebellion against the time it was given. We are left with a 6% gap that is currently swallowing our entire understanding of cosmic history. And as the golden mirror of Webb continues to stare into the infrared dark, it is becoming clear that the answers will not be found by tweaking the math. They will be found by accepting that the story we have been telling ourselves about our origins is missing its most important and most dangerous chapter. We went looking for the beginning, but we found that the beginning itself is shifting beneath our feet, leaving us with a universe that is younger, faster, and far more mysterious than we ever dared of cosmic history. We are forced to confront a possibility that is perhaps more unsettling than the idea of a broken timeline, the possibility that we are being lied to by light itself. Throughout this investigation, we have treated the red monsters and the impossible maturity of galaxies like JADES-GS-Z14-0 as physical facts, concrete objects that occupy a specific point in time and possess a specific, reality-defying mass. But what if these giants are merely phantoms? What if the architecture of cosmic rebellion is not a rebellion of matter, but a masterpiece of deception authored by the very geometry of the universe? This is the core of the cosmic imposter theory, a fringe but increasingly relevant explanation that suggests the impossible galaxies aren't actually too big or too early. They are simply caught in a hall of mirrors. To understand this deception, you have to look back at the very first deep-field image released by the James Webb Space Telescope in July 2022. It was a patch of sky known as SMACS 0723. And while the world was mesmerized by the sheer number of galaxies, astronomers were fixated on the ghostly shapes and warped arcs that seemed to stretch and curve around the center of the frame. These were not errors in the telescope's optics, they were fish lens effects created by gravitational warping. This is the phenomenon of gravitational lensing, a direct consequence of Einstein's general relativity. Einstein proved that mass does not just sit in space, it warps it, like a bowling ball placed on a trampoline. When a massive object, like a cluster of galaxies, sits in the foreground, it curves the fabric of space-time so severely that the light from even more distant galaxies traveling behind it is forced to follow that curve. In this scenario, the foreground cluster acts as a natural magnifying glass, a telescope built by gravity itself. It magnifies, it reveals, and it lets us peek behind the curtain of the deep past. Without this natural assistance, many of the most distant objects we've discussed would be far too faint for even Webb's golden mirror to detect. But this magnification comes with a dangerous price. It distorts our perception of reality. When you look through a magnifying glass, the object on the other side appears larger and brighter than it truly is. If you didn't know you were looking through a lens, you would assume the object was a giant. This is the cosmic imposter at work. Could it be that the too early, too big problem is actually a too much magnification problem? Take the case of the lensed quasar J0439 + 1 634. Its light was so distorted and amplified by a foreground cluster that it appeared thousands of times brighter than it actually was, providing a window into the deep past that should have been closed to us. If the early universe is more crowded with these gravitational lenses than our models predict, we might be systematically overestimating the mass and luminosity of everything we see at the edge of time. We see a red monster and calculate it has the mass of 1 billion suns, but in reality, we might be looking at a much smaller, ordinary hut that has been stretched and brightened by a cosmic fluke. But the cosmic imposter theory goes even deeper than simple magnification. It suggests that the very geometry of the universe might be warped on a global scale. Most of our cosmological models, including the standard lambda cold dark matter framework, assume that the universe is flat, meaning that on the largest scales, light travels in straight lines, and the geometry of space follows the rules we learned in high school. This assumption is supported by our measurements of the cosmic microwave background. However, if the universe possesses even a slight global curvature, what some call the curved universe theory, then every distance calculation we've ever made is wrong. In a curved universe, space acts like a giant lens itself. As light travels across billions of light years, the curvature of the cosmos could zoom in on distant objects, making them appear more mature and more massive than they actually are. It would be the ultimate cosmic imposter, a universe that looks younger or older, depending on the shape of the road the light had to travel to reach us. If the geometry of the universe is not what we thought, then the photo album paradox is solved not by changing the age of the stars, but by admitting that our zoom lens has been miscalibrated for a century. This isn't just theoretical speculation. We have seen the universe playing these tricks in real time. In September 2023, Webb spotted a supernova nicknamed SNH0PE that had been triply lensed by a galaxy cluster. Because the light from the same explosion took 3 different paths through the warped space, the supernova appeared in 3 different places in the image at 3 different times. It was a cosmic time delay, a playback of the same event happening over and over again. This proves that the geometry of space can literally manipulate our perception of time. If we are seeing impossible galaxies, could we be seeing multiple images of the same structures, or images that have been time-shifted by the path they took through the void? There is also the disturbing possibility of Doppler bias. We've noted the isotropic imbalance, the fact that galaxies in certain regions of the sky seem to have a preferred spin direction, which violates the idea that the universe should look the same in all directions. While some suggest this means the universe itself is rotating, others argue it is an observational artifact. Our own motion through space as the Milky Way drifts toward the Great Attractor could be creating a subtle blue shift or redshift bias that makes certain galaxies appear brighter or more evolved simply because of the angle at which we are viewing them. If we accept the cosmic imposter as a valid participant in this mystery, we must face a sobering reckoning. We have built our entire history of the cosmos on the assumption that what we see is what is actually there. We assume that a red smudge is a distant galaxy, that its brightness equals its mass, and that its distance equals its age. But the imposter suggests that the early universe is a hall of mirrors, where gravity, curvature, and motion are all conspiring to trick our senses. The red monsters might be little red dots that are closer than they appear. The cathedrals might be huts that have been magnified by the weight of the foreground. This leads us back to the most fundamental question of this investigation. Are we witnessing a rebellion of physics or a failure of observation? The cosmic imposter theory provides a bridge between the two. It suggests that the impossible galaxies are real, but our interpretation of them is being distorted by a geometry we don't fully understand. We are like ancient sailors trying to map the world while ignoring the curvature of the Earth. Our local measurements are perfect, but our global map is a disaster. The deeper Webb looks, the more of these warped arcs and lensed ghosts it finds. It is revealing a universe that is far more optical and far more deceptive than the static, predictable void of our old textbooks. We set out to find the beginning, but we may have found that the beginning is being projected onto a screen of warped space-time, magnified and distorted until it no longer resembles the truth. If the universe is an imposter, then the crisis isn't in the stars, it's in the lens. But even if we can explain away the brightness and the size through the trickery of lensing and curvature, there is one thing the imposter cannot easily hide: the structure. Even a magnified image of a chaotic mess should still look like a chaotic mess. Yet, as we will see in the next chapter, Webb has found something that no magnifying glass can explain away. It has found order in the middle of the storm, a big wheel in the dark that shouldn't just be too big, but should be too organized to exist in a universe that was supposedly still in the middle of a chaotic birth. If the light is lying about the size, is it also lying about the shape? Or have we truly found a ghost that refused to wait for time? Imposter theory suggests our eyes are being tricked. By the magnification of space, we are still left with a physical piece of evidence that no lens can fake: the geometry of absolute order. Even if a gravitational lens can make a galaxy appear 10 times larger or 100 times brighter than it truly is, it cannot fabricate a complex, organized internal structure where there should only be a chaotic mess. This brings us to the most haunting spectre currently inhabiting the early universe, a discovery that has turned the photo album paradox into a full-scale scientific haunting. In early 2025, the James Webb Space Telescope locked its gaze onto a structure that has come to be known as the Big Wheel. It is a massive spiral galaxy, complete with elegant sweeping arms and a rotating disk, existing within the first 2 billion years of cosmic history. To the casual observer, it looks like a beautiful, standard portrait of a galaxy like our own Milky Way, but to a cosmologist, the Big Wheel is a ghost that refuses to wait its turn in the timeline of reality. Finding the Big Wheel in the early universe is like walking into a kindergarten classroom and finding an elderly person calmly filing their taxes. It is not just that they are too big or too early, it is that they possess a level of maturity and organization that requires a lifetime of experience that the universe simply hasn't had yet. According to every simulation ever run on our most powerful supercomputers, spiral arms are a late-stage feature of galactic evolution. They require billions of years of calm gravitational settling to develop, a patient, silent choreography where gas and stars slowly find their equilibrium and settle into an orderly rotation. The early universe was supposed to be the antithesis of calm. It was meant to be a cosmic construction site, a violent, high-pressure environment of non-stop collisions, chaotic mergers, and the blinding radiation of the first stars. In that screaming hot plasma and turbulent gas, structure shouldn't have had the room or the time to breathe, let alone to dance. Yet the Big Wheel sits there, a massive, rotating adult in a room full of infants. Its existence suggests that structure emerged from the primordial chaos far faster than the laws of gravity should allow. To understand the depth of this contradiction, you have to understand the hierarchical model of galaxy formation that has been the bedrock of astronomy for 30 years. This model tells a story of patience. It says that after the Big Bang, the universe was a nearly uniform soup of gas that slowly clumped together under the pull of dark matter. Small things formed first, tiny, irregular huts of stars, which then gradually merged over eons to build larger and larger structures. It was a bottom-up crawl. Our own Milky Way was thought to have taken at least 1 to 2 billion years just to reach its teenage phase, and billions more to achieve the elegant spiral structure we see today. But the Big Wheel and its smaller predecessor, a galaxy named Rebels, have skipped childhood entirely. Rebels 25, discovered by the Atacama Large Millimeter Array, was found to be organized and rotating just 700 million years after the Big Bang. It wasn't messy, it was neat. It had a rotating disk and even signs of a central bar, features we usually associate with mature, senior galaxies that have had billions of years to settle. When Webb followed this trail to the Big Wheel in 2025, the discrepancy became impossible to ignore. We are seeing cosmic cities glowing where there should have been nothing but scaffolding. The buildings are finished, the lights are on, and the residents are moving in before the construction crew has even arrived at the site. The too early too big problem was a crisis of mass, but the Big Wheel is a crisis of dynamics. If you have enough gas and enough gravity, you can theoretically build a monster galaxy quickly, but building an organized galaxy is much harder. It is the difference between a pile of bricks and a finished cathedral. A spiral galaxy is an ordered system where gravity has had a total, uncontested victory over the forces of internal pressure and radiation. For the Big Wheel to exist within the first 2 billion years, one of two impossible things must be true. Either the galaxy assembled its massive weight in an unusually peaceful way that allowed structure to form without the violent interruptions of mergers, or it formed most of its stars in place, collapsing from a single, gargantuan cloud of gas that ignored the hierarchical rules of the Standard Model. Both explanations are a threat to our current map of reality. If these galaxies formed in place and skip the merger phase, then the dark matter halos that we use as the scaffolding for our universe aren't working the way we thought. We assumed dark matter was cold and sluggish, clumping together in a way that forced a slow, hierarchical merger of small pieces. But if structure can appear monolithically and rapidly, then the DNA of the universe's scaffolding might be fundamentally different. We might be looking at a universe that isn't built of bricks, but one that crystallized out of the Big Bang, already possessing a memory of its final shape. This leads us back to the architecture of cosmic rebellion. We are finding that the cosmic dawn was less of a slow, gentle awakening and more of a sudden, hyper-efficient ignition. The universe didn't grow up the way we were told. It arrived already old, already structured, and already rebelling against the time it was given. Some researchers are now pointing to the isotropic imbalance, the strange observation that galaxies in the early universe seem to have a preferred spin direction, as a clue to this prepackaged order. If the universe itself has an inherent twist or rotation, it might have imparted a directional bias to these early structures, helping them settle into rotating wheels of stars far faster than a random and directionless Big Bang would allow. The psychological weight of the Big Wheel is that it removes the last exit ramp for the Standard Model. We could blame the little red dots on black holes pretending to be stars. We could blame the red monsters on a high-efficiency star formation mode. We could even blame the mass on gravitational lensing trickery. But you cannot lens a spiral arm into existence. You cannot use a black hole to fake an organized rotating disk of 100 billion stars. The Big Wheel is a physical reality that exists in a region of time where it should be a chaotic wisp of hydrogen. As we stare at these adults in the maternity ward, the question is no longer just, what did we miss, but what is the universe actually made of? If gravity could produce this level of order in a fraction of the time we predicted, then the speed limit of cosmic evolution is much higher than we ever imagined. Or perhaps more disturbingly, the clocks we are using to measure the age of the universe are fundamentally broken. If the universe is actually much older than 13.8 billion years, as the Hubble tension and the Methuselah star hint, then the big wheel has plenty of time to form. But to accept that, we have to throw away the most successful cosmological model ever constructed. The scientific community is now standing at a reckoning. We are like ancient sailors who have found a modern city on an island that wasn't even on the map. We are finding that the dark ages were never dark, and the cosmic dawn was never a quiet sunrise. The early universe was a howling void of rapid construction where structure didn't just emerge, it erupted. The big wheel is the ultimate proof of this rebellion, a ghost of impossible maturity that suggests the story of our own origins is missing its most important and most dangerous chapter. And as the golden mirror of Webb continues to turn the pages of this impossible photo album, it is becoming clear that the answers will not be found by tweaking the math of star formation. They will be found by embracing the fringe, the radical theories of modified gravity, oscillating energy, and a universe that might be far older, stranger, and more alive than we were ever meant to know. In the next chapter, we look at the radical solutions to this crisis, where the laws of gravity themselves are being put on trial for the crime of being too slow for the universe we actually inhabit. When you have exhausted every logical explanation, when you have stripped away the illusions of gravitational lensing and the masks of hungry black holes, and the math still refuses to balance, you are left at the edge of a precipice. This is the territory of the fringe, the place where the most brilliant minds in the world stop trying to fix the old map and start drawing a terrifyingly new one. We are now entering the era of the great cosmological reckoning, where the architecture of cosmic rebellion forces us to ask a question that was once considered scientific heresy. What if the very laws of physics were different when the universe was born? If gravity and the push of the vacuum are not the constants we believed them to be, then the impossible maturity of the big wheel and the chemical ghosts of JWST-GS-Z14-0 are not anomalies at all. They are the logical results of a universe that operated on a different set of rules. To understand the first radical solution, we must look at the most invisible ingredient in our current reality: dark matter. For 40 years, dark matter has been the invisible hand of the Standard Model, the silent architect that provided the scaffolding for every galaxy in existence. We believe it outweighs ordinary matter 5 to 1, and yet, despite every experiment and every billion-dollar detector, we have never actually seen a single particle of it. It is a placeholder, a variable we added to the equations because the gravity of the visible stars wasn't strong enough to hold galaxies together. But as the red monsters of the early universe appear with twice the mass they are allowed to have, a growing group of rebels is asking if we've been chasing a ghost. Enter MOND, or modified Newtonian dynamics. This theory suggests that we don't need invisible matter to explain the universe. We just need to admit that our understanding of gravity is fundamentally incomplete. MOND proposes that on the massive cosmic scales of a galaxy, where accelerations are incredibly low, gravity doesn't fade away according to the rules of Newton or Einstein. Instead, it stays strong. It's as if the rules of the road change the further you get from the city. In our local solar system, gravity behaves exactly as we expect, but at the edges of a galaxy, it enters a boosted mode. If gravity was indeed stronger in the low-density environment of the infant universe, then the oak tree of JADES-GS-Z14-0 didn't need millions of years of patient growth. It would have been pulled together with a ferocity that bypasses the slow bottlenecks of gas cooling and stellar feedback. Structure wouldn't have emerged, it would have erupted, driven by a version of gravity that was optimized for construction rather than stability. But if gravity is the pull of the universe, then the other side of the coin is the push, what we call dark energy. In the Standard Model, dark energy is a cosmological constant, a smooth, unchanging energy density that fills every cubic centimeter of the vacuum, pushing space apart at a steady, predictable rate. But this constant is exactly what the Hubble tension is currently shattering. If the two clocks of time don't agree, it may be because the push of the universe hasn't been a steady flow, but a series of violent, unpredictable lurches. This is the theory of oscillating dark energy. Imagine a car attempting to merge onto a highway. Instead of a smooth acceleration, the driver slams their foot on the gas, creating a sudden, neck-snapping lurch before settling into a cruise. The theory of oscillating dark energy proposes that right after the Big Bang, the universe experienced an unexpected kick, a burst of rapid expansion and energy that fundamentally altered the conditions for structure formation. This kick would have acted as a cosmic pressure cooker, squeezing the primordial gas and dark matter together with an intensity that the standard smooth model cannot replicate. This would explain the efficiency mode we see in the early galaxies, where every atom of gas was forced into a star with 100% productivity. The universe wasn't being patient, it was being driven by a vacuum that was pulsing with a raw, unstable energy that eventually settled into the quiet expansion we see today. These theories, MOND and oscillating dark energy, are more than just mathematical tweaks. They represent a paradigm shift that threatens to rewrite every textbook in existence. They suggest that we are living in a universe that is far more alive and far more unpredictable than the static, mechanical model we've been taught. If the laws of physics can change, then the timeline of the universe is not a fixed 13.8 billion-year track, but a shifting, evolving narrative. This would solve the photo album paradox by admitting that the baby photo we've been looking for doesn't exist because the baby was born into a reality that allowed it to grow up in a heartbeat. The psychological resistance to these ideas is immense. For decades, the lambda cold dark matter model has been the masterpiece of prediction, a beautiful, internally consistent story that accounted for almost everything we saw in the sky. To throw it away for the fringe feels like admitting we have been lost for a century. But as the big wheel and the red monsters continue to stare back at us through the golden mirror of Webb, the scientific community is being forced out of its comfort zone. We are finding that nature is under no obligation to make sense to us. And the architecture of cosmic rebellion may simply be the way the universe works when no one is watching the clock. There are even more radical ideas emerging from this chaos, ideas that link these fringe theories to the very shape of the universe. Some researchers are looking at the isotropic imbalance, the strange bias in the spin of early galaxies, and wondering if this is the fingerprint of a rotating universe. If the universe itself is spinning or was born inside a rotating black hole, then the extra gravity we see in MOND and the extra push we see in oscillating dark energy might just be different faces of the same primordial motion. We would be living inside a colossal, rotating engine where structure is mandated by the spin of space itself. As we move toward the final reckoning of this investigation, we have to accept that the cosmological crisis is not a failure of our telescopes, but a victory of reality over our expectations. We set out to find a simple origin story, a scrambled egg that we could easily unscramble with enough math and enough time. Instead, we found a universe that arrived already complex, already mature, and already breaking its own rules. The fringe theories are the first attempts to build a language for this new reality, a way to describe a cosmos that grew up too fast, moved too aggressively, and forged its chemical heart in a pre-dawn fire that we never knew was burning. If gravity is different, and if the vacuum can pulse, then the impossible galaxies are actually the only things that make sense. They are the survivors of a more violent, more productive era of existence, ghosts from a time when the rules of the game were skewed toward creation. We are now forced to expand the map to include the invisible hands and the cosmic kicks that we once dismissed as too extreme. Because at the end of the day, the data from Webb is not a mistake, it is a signal. And that signal is telling us that the architecture of cosmic rebellion is not just a mystery to be solved, but a new foundation to be built. In our final chapter, we will bring all these threads together, the oak tree, the little red dots, the two clocks, and the fringe to see what the corrected picture of reality actually looks like. We will find that the universe is not broken, but it is far more alive and far more dangerous to our old ways of thinking than we ever imagined. We are not just rewriting the history of the stars, we are finding a new origin story for ourselves in a universe that refused to wait for time to tell it what to do. Tonight we realize that the universe didn't just wake up, it exploded into consciousness with a ferocity that our history books were never designed to contain. For decades, we felt safe in the neat chronological lines of our cosmic timeline. We told ourselves a story of a slow, cooling fog and a patient architect named gravity. We believed we were the final, refined product of a long, quiet labor that took billions of years to bear fruit. But the data from the James Webb Space Telescope is no longer whispering, it is screaming. It tells us that the cosmic dawn wasn't a gentle, predictable sunrise. It was a sudden, violent, and hyper-efficient ignition. We see adult galaxies where there should be formless infants. We see monsters without parent stars. We see a reality that arrived already structured, already chemically rich, and already rebelling against the limits we tried to set for it. This isn't just a crisis for professional cosmologists. It is a reckoning for humanity. Because if we were wrong about the beginning, we are forced to ask, what else have we missed about the nature of our own existence? As we stand at the end of this investigation, we must first address the sensational headlines that have echoed through the digital void. The claim that the Big Bang itself is dead. The truth is far more nuanced and, in many ways, far more exciting. The Big Bang model, the idea that the universe emerged 13.8 billion years ago from a state of incomprehensible density, remains the most successful framework in human history. It still perfectly predicts the temperature fluctuations in the oldest light, the abundances of hydrogen and helium, and the large-scale distribution of the cosmic web. The universe is not broken, and the standard model is not in ruins. Instead, what we have discovered is that our map of the early universe was drawn with a limited set of tools, leaving massive, unexplored territories that Webb is only now beginning to populate. We have learned that the cosmological crisis is not a failure of our telescopes, but a victory of reality over our expectations. The distinction is critical. The fundamental laws of cosmology, the expansion history, and the energy budget remain consistent, but the galaxy formation models we built on top of them have been shattered. We were wrong about how galaxies were built, how quickly they grew, and how efficiently they forged the elements that make up our bodies. We expected a leaky faucet of star formation where 90% of the gas was wasted, but in the infant universe, we found a high-pressure fire hose where every atom was drafted into the service of creation. Think back to the record breaker that started this journey, JWST-GS-Z14-0. This galaxy, existing just 290 million years after the Big Bang, remains the oak tree in the flower pot that refuses to be explained away. It isn't a wisp of gas, it is a 1,600 light-year city of hundreds of millions of stars already speedrunning the process of evolution. The detection of oxygen within its light is the chemical smoking gun of this rebellion. It proves that the Dark Ages were never truly dark. They were an era of intense, hyper-efficient stellar life and death that occurred in the absolute dark before we even knew the theater was open. This galaxy and the red monsters found in its wake suggest that the infant universe was running on a turbo mode, where stars formed at rates 10 to 20 times faster than anything we see today. Even the little red dots, those predatory monsters in disguise, have forced us to reconsider the speed of destruction. By discovering supermassive black holes that weigh millions of times more than our Sun just 400 million years after the Big Bang, the universe has effectively broken the speed limit of cosmic growth. Whether they were born through the monolithic direct collapse of gas clouds or grew from exotic supermassive primordial stars, they tell us that the early universe was a place where giants were born without mothers. They prove that the history of structure is not a slow climb, but a sudden eruption from a vacuum that was far more productive and dangerous than it is today. But the architecture of cosmic rebellion is not just about mass and light, it is about order. The discovery of the Big Wheel spiral galaxy and Rebels 25 has shown us that organized rotating disks emerged from the chaos in a fraction of the time predicted by our simulations. Finding these structures so early is like finding an elderly person in a kindergarten classroom. It suggests that the DNA of the universe's scaffolding might be fundamentally different than we assumed. It hints at a prepackaged order, perhaps inherited from a primordial spin or a geometric memory from a parent universe, which helped structure crystallize out of the Big Bang with an inherent, graceful geometry. This rebellion has also manifested in the two clocks of the Hubble tension, where our measurements of the present-day expansion and our projections from the past simply refuse to agree. This 6% gap is not a rounding error. It is an earthquake that could potentially shrink the age of the universe by 1 billion years. If the universe is younger and faster than we believed, then the photo album paradox becomes an existential nightmare. Every stage of evolution, every chemical process, and every structural assembly had even less time to occur in a window that was already too narrow. It implies that we have missed a missing chapter in the equations of reality, a hidden force, a pulsing energy, or a version of gravity that was optimized for construction rather than stability. We have been forced to look at radical, fringe solutions to balance the books. Theories like MOND suggest that gravity stays stronger on cosmic scales than Einstein predicted, allowing for the rapid eruption of structure. Oscillating. Dark energy proposes that the vacuum of space gave the early universe an unexpected kick, acting as a pressure cooker that squeezed matter into galaxies with an intensity we cannot replicate in the modern era. Even the cosmic imposter theory warns us that we may be staring through a hall of mirrors where the global curvature of space or the magnification of gravitational lenses is distorting our very perception of mass and time. But as we expand the map to include these invisible hands and cosmic kicks, we realize that the universe we are discovering is far more alive and far more aggressive than the static, mechanical model of our old textbooks. The cosmic dawn was not a quiet, gentle awakening. It was a howling void of rapid construction and efficient destruction. It was a period where the universe arrived already old, already structured, and already chemically rich. So, where does that leave us? It leaves us with a new origin story. We are not just a random coincidence that appeared after eons of patient cooling. We are the direct descendants of a cosmic rebellion. The iron in your blood, the oxygen in your lungs, and the carbon in your DNA are not just star stuff. They are the remnants of a specific, violent, and hyper-efficient era of history that forged the ingredients of life at the absolute dawn of time. The proto-galaxies that Webb is now detecting are our ancestors. They are the building blocks that merged, collided, and evolved into the Milky Way we inhabit today. The universe is always ahead of us. Every time we build a better telescope, we don't find the beginning. We find that the universe was already busy doing remarkable things long before we thought it was possible. This capacity for surprise is not a failure of science. It is the engine of science. We are the first generation of humans to see this part of our biography, and the message we are receiving is that we have only just begun to read the first page. We were wrong about the first galaxies, but we were wrong in the best way possible. We were just wrong enough to discover something bigger, stranger, and more profound than our models ever imagined. The Big Bang didn't give us a baby photo to cherish, it gave us a rebellion to solve. And as the golden mirror of Webb continues to turn the pages of this impossible album, we must be ready for the next chapter. Because the architecture of cosmic rebellion is not just a mystery to be solved, it is the foundation of who we are. We are the product of a universe that refused to wait for time to tell it what to do. And tonight, through the quiet act of wondering, we have joined that rebellion once again. The map is growing, the clocks are ticking, and the story of our origins is finally, for the first time, beginning to match the scale of the universe itself.